Hi everyone, welcome to my channel. You are most welcome to be watching these videos, and subscribe for more so that when I post a new video you're able to see it and watch and learn. Okay, so to dive into today's lesson, we're going to look at the laws of indices. Okay, we're going to look at the laws of indices. So there are basically three laws of indices that we need to know. We have the first law, the second one, and the third one. So when you look at the first law, it's saying when you have a base that is the same, okay, you have a base that is the same with different exponents being multiplied to each other. So you have this base and this base, they're actually the same, but they have different exponents and they're being multiplied to each other. What you need to do is to get that single base raised to the addition, okay, or raised to the sum of those exponents. Okay, so you just raise the base, you raise it to the sum of those two exponents. Let's look at an example so that we can really understand what is happening here. Okay, so an example would be, okay, let's say you have 2 raised to the power of 2 plus 2 raised to the power of 1. Or we need to multiply here, sorry for that. So we are basically multiplying here. So you have 2 raised to the power of 2 multiplied by 2 raised to the power of 1. Now, you can see that the base is basically the same. So the base is a 2 here, and the base is a 2 here. But when you look at the exponent, here we have the m as the exponent. In this case, it's the 2. We have the n here. In this case, it's the 1. The bases are different. So what you need to do here is to just get the base, which is the 2, then get the exponent and add them. Okay? So once you do that, you can see that you're adding 2 plus 1 with a single base because the bases are the same. So this will give us 2 to the power what? 3. That's what the law, the first law says. Okay, if you have 2 bases which are technically the same, raised to different exponents, what you need to do is to get that base raised to the sum of those 2 exponents, and that's what we have done here. And from there you can easily simplify, or rather evaluate to find the final answer. Another scenario would be, let's say you have 10 raised to the power of 0 multiplied by 10 raised to the power of 3. Okay, in this case you do the same. The base is 10 raised to the power of 0 plus what? 3, and the answer will be 10 to the power of 3. You can simplify this and find the final answer, but basically that's what the law says. Okay, so you use this law to actually simplify this kind of a thing so that you can have just 10 raised to the power of 3. Okay, so we can go on and on giving examples, but basically this is what the first law says. Okay, that's what it's saying. Okay, with that said, we can go to the law number 2, okay, or the second law. Now, the second law that we have here is saying, given a base that is actually in the brackets raised to some exponent m, okay, then enclosed in brackets, then raised to the exponent n. What we can do here is just get the base and multiply the 2 indices. Okay, you multiply the m that is inside with the n that is outside. This is quite easy to understand. Now here's an example that can really make the things easy for us. Okay, so let's say you have 6 raised to the power of 3. Okay, then all this is raised to the power of 2. Okay, so now you can see that the 6 is standing in for the base, which is n. Then the m in this case is 3. Then the n in this case we have, it's actually the 2. So what we can do here, using this law, we can say 6 raised to the power of 3 times 2, which will just give us 6 to the power of what? 6. Okay, so we have 6 raised to the power of 6, which is quite easy. Okay, because we know now we just need to expand 6, rather multiply 6 to itself 6 times and evaluate and find the final answer. But basically, I'm trying to make you understand that this law can be translated as something as having something like this, then going through up to this point. Okay, where you have 6 raised to the power of 6. Okay, so with that said, you can also look at another example. Let's say you have maybe 1 raised to the power of 3. Okay, not 3, too much of 3. You can use even the 7. Okay, 1 raised to the power of 7. Then outside we have 3. You can use it, it's fine. Okay, so here we'll have 7 multiplied by what? By 3, and we'll have 1 raised to the power of 21. That's what it means. Okay, that's what this second law means. So we can solve so many questions using this trick, so that we can just have one thing to deal with, instead of, first of all, you deal with what is inside, then again you come and deal with what is outside. You can deal with them by just multiplying these two exponents together and get the product as 21. Okay, I hope that is clear to us, so that we can proceed to the last law, okay, and look at some examples that we can solve. Okay, so now on the last part we have this part here where it's saying some base, given some base raised to the exponent m over n raised to the exponent n, this should equal to the base m minus n. Okay, so this is quite easy, but then when you look at it from this aspect, it might confuse you. But let's look at it from this aspect. Okay, let's say you have some base, like let's say you have 8 raised to the power of 5. Then down here, or you have 8 raised to the power 2. So what that means is that when you have the same base but different exponents, you are dividing. The easy thing that you can do, instead of multiplying this and find the final answer, or rather evaluating this to find the final answer and evaluating this, the easiest that you can do, because you know, as mathematicians, we always want to find the easy way of doing things. If you're not lazy as a mathematician, then I don't know what kind of a mathematician you are. Because as mathematicians, we always try to find better ways of solving certain questions. So we're not saying this is using this law is the only way on how you can go about solving this question. No. What we're saying is, what is the most effective way, or what is the most not time-consuming way of solving this kind of a question? Because the other way can be, you expand this, find the answer there, okay, and expand this and find the final answer. Then divide those answers, because there'll be numbers, okay, and then you can easily find the answer that is supposed to be there. But what we are saying is, instead of doing all that, what is the easiest way? So the easiest way here can be, because the bases are the same, you can just write 8, 5 minus 2, and this will definitely give you 8 to the power 3. Now you can see that instead of trying to evaluate 8 to the power 5, 8 times 8 times 8 times 8, 5 times, and then find the final answer, divide by 8 times 8, which is 64, it will give you some bigger number. Then you need to divide. Then after dividing, that's when you are going to find the answer that you are going to find if you just evaluate this. Okay, so this is easy, because that is just basically now 8 times 8 times 8. You don't even need to do much work. So you can see that as mathematicians, we always try to find easier way on how we can actually be solving these complex problems. Okay, so that's what this law says. Okay, we can even look at another example. Okay, Okay, instead of looking at that one, let's say we have a complicated one now. Let's say you have 12 raised to the power of 20, okay, over 12 raised to the power of 15. Now, here, if you wanted to use that other method of evaluating the numerator and finding the final answer, then divide by the denominator here, it's going to consume a lot of time. Okay, it's going to consume a lot of time, unless you're using a calculator. Yes, that way it's going to be effective. But then if you're trying to solve on your own, it's going to take you much time. So the easy way to go about this, because the bases are the same, the exponents are different, and you're dividing, here you can just say 12, 20 minus 15, and this will be simplified to 12 to the power 5. Okay, you can see that that is easy now. Okay, you can deal with that. 12 times 12, meaning multiplying 12 to itself 5 times. That is easy, because it has the law here has helped us to simplify this to a better size. Okay, so that is basically how you go about solving questions using the laws of indices. Okay, so now before we try to look at maybe some examples, or some examples of how we can actually solve. Okay, the other thing that you need to take note of is that there's even important points, like in a situation where you have this kind of a setup, like for example you have a base a raised to the exponent negative m. Okay, usually you have those situations where you have the base a raised to the exponent m. How do you find the final answer in that case? So what you do basically there is you introduce a special one. Okay, you introduce a special one in this case. So you want to get rid of the negative sign on the index or the exponent. So what you do here, you're going to say 1 over a raised to the power of m. So you can see that because of the one that we have introduced on the numerator there, it has consumed the negative that we had. So this is really important to take note of, because there will be questions that they'll actually give you that will require you to use this skill that you have learned today. So it's very important that we know that if you have a negative exponent, write what you have here under a 1. So the 1 should be on the numerator, then this negative will actually automatically go. Okay, it will go. Then the other point that you need to take note of is that if we have a base a raised to the power of 0, this will give you what? This will give you 1. Okay, so any number raised to the power of 0 will give you 1, regardless of the number that you're given. It might be 1 million. If it is raised to the power of 0, it has to give you 1. Okay, so these two things that you have here, they are very important to note, because, or to take serious note of them, because you might be stuck when you're given something like this. So it's very important that you get to know how to deal with this. Now let's get into examples where we are going to use these laws of indices, as well as using part of this to solve the questions that are going to be given to us. Okay, let's look at those examples. So examples, let me just check on my examples that I have here. Okay, I have some examples that we can actually solve. So we have example 1. Example 1 would be simplify the following. So we are going to simplify. So simplify the following. Simplify the following. So part A will have 3 raised to the exponent 2 multiplied by 3 raised to the exponent negative 3. Part B, we can have part B, we can have another question. Let's look at another question that we can have. Okay, we can look at another question that we can have. Okay, let's say you have this question here. You have 2 raised to the power of 4 in brackets raised to the power 2. Okay, then C, we can have another question that will have, let's say we have 4 raised to the power of 3 over 4 raised to the power of 2. So let's look at those examples and see what we can do. Okay, so I'll solve the first one this way. Okay, so if you want to solve the first one, so this side will actually have solution. So the first one, you can see that this is basically the first law. We need to use the first law of indices. So the first law of indices here stipulate that if you have the same base and different exponent, we just basically add the exponent. So here we are saying, so part A will have 3 as the base, and then 2 plus negative 3. And this will give us 3 2 minus 3, which will just give us 3 to the power minus 1. Now, if you have 3 raised to the power minus 1 or raised to the index negative 1, I think that's not I think, but this is where you actually use that concept that we learned, and this is the concept where you have a base raised to the negative exponent. We said in this case you just write this under a 1 and the negative exponent becomes positive automatically. So we can do the same here. So we are going to say 1 over 3 raised to the power of 1, and this will just give us 1 over what? 1 over 3 as the answer. Okay, so you can see that it was easy for us to solve without much struggle because we know the laws of indices that we need to follow. Okay, you can go to part B. Okay, so part B, we have 2 raised to the exponent 4 in brackets raised to the exponent 2. So we have 2, 4, then 2 as well here. So we can use the second law of indices. What does it stipulate? It says that we need to multiply these two exponents. So we have 2 raised to the power of 4 times what? 4 times 2. And this will give us 2 to the power 8. So what is 2 to the power 8? We can actually find the answer by actually multiplying. So 2 to the power 8 will give us what? Let's try to do it. So we're going to say this will equal to 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8. Let's try and see the answer that we're going to get here. 2 times 2, 4. 4 times 2 will give us 8. 8 times 2, 16. 16 times 2 will get 64. 64 times 2 will get 128. Now there, 128 times 2. Okay, so we need to multiply 128. 128 multiplied by 2 will get 256. 256 multiplied by 2 will get 512. So the answer that we need to get here, it's basically 500 and what? 512. So this is the answer we're going to get when we simplify this part here. So 2 raised to the exponent 8 will give us 512. So it was easy for us to solve because we used the second law of indices. Now with that said, we can also try to solve the last part. Okay, so the last part, I'll solve it from the upper part. Okay, I can even wrap everything, okay, so that we can solve the last one. Okay, so how do we go about solving the last one? We'll have, so this is part C. We have 4 raised to the power of 3, or rather exponent 3, over 4 raised to the exponent 2. So if we have the bases that are the same, the third law of indices stipulates that if the bases are the same raised to different exponents, we just need to get one base, which is a 4 in this case, then subtract the exponent. So this is going to be 3 minus 2, and our answer will be 4 to the power 1. But then, what is 4 to the power 1? 4 to the power 1 will have it that we'll just have 4 as the answer. So any number raised to the power of 1, the answer is actually the number itself. So that's how you go about solving that one. How about I give you an exercise? So let me give an exercise that we can actually solve. Okay, so I'll use this part here to give the exercise, and I'll wrap this part. Let me write exercise there, or task. Okay, so simplify the following. Part A, I want you to do or to solve 3 to the power 0 multiplied by 3 to the power minus 1. Okay, how do you go about solving that kind of equation? Then part B, you can solve this one. You can solve 5 raised to the power negative 4 over 5 raised to the exponent 2.